Setting it up. All right, we're recording. Welcome to everybody. So we're going to have a discussion tonight about multisensory math, the ASDEC courses, whether someone wants to or decides to do more than just the course. And so first thing, you'll look at the bottom of your screen on Zoom, you'll see a react. Those of you who teach elementary school, K-5, I want you to give me a reaction like something on your screen. If you teach elementary school, give me a reaction. Let me know where my elementary school people are. All right. And do I have anyone in here? Good. Do I have anyone in here who is a secondary teacher? So I'm going to let you give me another kind of uh, sign. If you are a secondary teacher, let me know whether you teach secondary math. That would be K-8 or algebra or geometry. And then another thing that will help me guide the discussion, if you can put in the chat what your interest is in multisensory math. So if I know what's guiding your questions, I can actually steer some of the conversation that direction. So in the chat, are you a classroom teacher and you want to know how to be more effective with your students? Are you a parent? Are you of a student who has dyslexia or a language-based disability? Are you someone who, oh, Jenny, what a great answer. I'm with you to help overcome your own math trauma and help my students. I want to preface this right now as we go into what the courses are, what they're like, what the practicum is like. There's a huge disagreement right now in math circles about math trauma. And some people say, oh, it's because of time drills and the Mad Minute. And other people say, it's just I constantly failed at math. And a lot of this we can attribute to instructional casualties. We have different philosophies about teaching math, and that is all evolving. There are now two philosophies that are sort of competing, and they all claim to have effective instruction. But in many cases, our students are really not learning. And we have specific points in the content where we can see we have a crisis right now in subtraction with regrouping, and in long division, and in multiplication fluency. So I'm looking at this. I love the answer because, Jenny, I have answers for you. I can't tell you how many people in my courses write in and say, gee, I wish I had learned this way. Gee, I'm finally understanding fractions. Or I knew how to teach the procedure, but not what it meant and how to think about it. So it's really good to hear that some of you are tutors. Yes, we know we can sense when some of our students just need more. And interventionists. So Robin and interventionists, math can be a struggle for so many students. And the kindergartens, the foundation upon which the rest of us stand. So parents especially get feeling like they've got problems because they go to the school and say, my child is failing, but I don't know why. And the teacher says, oh, they'll catch up. Or, well, we'll just give them a calculator. So we're going to be talking about that a little bit. My training, as I said, goes back 50 years in literacy. But when I started doing academic support in the early 1990s, I was tutoring at home. Students came to my house, and I could teach them to read, write, and spell. And then I noticed they were failing algebra. So I went to the person at ASDEC who was teaching the multisensory math course, and I said, I've got students who are failing algebra. So I took her course, and she had really great ideas, but she didn't do algebra. So I did. So in 2003, I started researching what was effective and what is it about multisensory that works in literacy, but nobody's doing it in math. And teachers are saying in third grade, throw out the manipulatives. We don't need those now. And indeed, we know that older students sometimes need them more than the younger ones because the math is becoming very abstract. So I'll give you a demonstration or two tonight and show you what we're doing. But let me just talk about what those ASDEC courses are, because trauma is one of them. We have a name for the gaps that students exhibit, and it's called unfinished learning. We get our students in fourth, fifth, or middle grades or middle school. They don't know their times tables. They can't add and subtract reliably. Some of them really don't fully understand place value. And so we see students who are really struggling and they don't know why. The parents don't know why. The teachers of older students aren't trained to teach foundation skills. And so that becomes a problem. So I just wanted to share my screen for a moment and talk about what our courses are and what we do with them. So what is this multisensory math thing? And what is OG or Orton-Gillingham math? And I didn't think to ask, but some of you said, oh, I have OG training. Could I see, some of you may not even know what OG is. So if you don't know what OG is, I can answer that question tonight if you can give me a sign that you really have not encountered OG. That would also help me. If you haven't encountered OG, have never heard of it, don't really know what it is, because it's not only reading. It's a way of learning. It's a way of getting the whole brain involved. And so if you're OG trained in any of the programs, you know what we're talking about when I say words like, sequential and structured and that sort of thing. So, okay, I'm looking. We have a new person. Do we have a new question here? Okay. All right. So Karen does know OG. So I'm going to explain who that is and what that is. But first, I'll talk about that history. I mentioned Montessori. So Montessori, you've all heard of Montessori schools, and we know they're hands-on, and they're in most communities now. It's a follow the child, kind of what is the child interested in, and we'll teach them the skills as we follow what they're interested in and what we sort of guide them to be interested in so that they gain knowledge and acquire skills. It was, I'm not going to say it was unstructured, but it was not explicit instruction. So there are some terms I'll use tonight, and if you don't know them, please let me know. But explicit instruction is where you give students skills. You explicitly teach them what something is. So I'll give you an example. When I asked an algebra teacher to define for me what a common denominator in fractions was, he said, oh, I would just first tell my students how to get it. And I said, no, that's not what a common denominator is. I want to know what it is so I can understand why I'm doing these procedures. And he couldn't give me an answer. Explicit instruction is where we show the students the meaning behind the math, like addition is putting together, and multiplication is making many of the same quantity, and division is separating apart. And for students to know the meaning behind it functions as an anchor. So as we look at what multisensory math is, at least my version of what multisensory math is, we need to look at what the possibilities are. And the first thing is that our courses at ASDEC are based on a rich history of that multisensory instruction. I have included this thing called the science of learning, which is a very hot topic right now, which is beside the point because when I go back to look at our instructional strategies, one of my goals is finding the evidence or research to support the different ways I'm teaching to reach all students. So I'm using the science of learning, which is where we have certain methods that we use to make sure students understand, but also retain what we teach. I'm also using evidence from a thing called the Institute for Educational Science. You may have heard of the What Works Clearinghouse practice guides, but it's a heavy body of research dating back, many, many, many years, back before we even had the neuroimaging. And through really rigorous research, we find, well, this strategy works and that one doesn't. Some of that goes back to study skills. I mean, we all know you should not cram for a test the night before a test. So how do we study? And we know that if you study in small increments and then go back and build on that, you don't forget as much. I'm also using evidence, emerging evidence for neuropsychology and cognitive psychology. So we have two multisensory math courses. So what does that mean? What is multisensory? The more of the brain involved in the learning, the more the student remembers and for a longer period of time and understands. And our first course deals with K-5 concepts, first in our grade bands K to 2 and 3, and then the second level, grades 3 through 6, going toward middle school. Sixth grade is now middle school. But we learn the meaning behind all the operations and concepts built on what is developmentally appropriate for all students. Now, in the 1990s, the National Council of Teachers of Mathematics created a thing called the focal points. And they were looking at what was developmentally appropriate for children to learn at different grades. I'm going to pin my video now so that I can also go to my document camera to give you some demonstrations. But for example, most people don't know that our preschool standards for math are actually vocabulary. Little kids need to know words like before and after. They need to know longer, shorter, greater, smaller. And there's a whole set of words that are part of our preschool curriculum. We know that it's developmentally appropriate for kindergartners to learn the addends of 5, but only that 3 plus 2 makes 5, 4 plus 1 makes 5. But what does that mean? If we only show them numbers, that's very abstract. If we only have them counting, what's the purpose of counting? Have you all ever seen a child who just counts and they say, I'm this many, or they count to 10 and they have no idea what they're doing? If it's only words, it doesn't create the imagination and imagery that they need in the brain to understand math. So we look at the developmentally appropriate pieces and we build that in. So we would do things like having children build the quantity 5 on a domino or put tally marks down and recognize that pattern. That's based on the neuroscience. And so we would learn to build our place value system. We would use manipulatives to anchor that child with imagery. And I'm going to illustrate that with you right now with one of our instructional strategies, and that is that using large motor muscles and something the child is familiar with can ground you in a concept. And though most of you are not algebra teachers, if I said to you, take your arm and imagine you're the quarterback on the football field and you're about to throw that pass down the field to the intended receiver. You can imagine that because it's within your knowledge base. And the trajectory of that ball would take a kind of a U shape, kind of like this. And that is the shape of one of our algebraic functions called a quadratic function. And we can teach from that memory piece all the associated information, that it has a maximum height that it achieves, or it has a minimum, or that as it goes across that field, the value or the height of the ball that's equal on either side of that shape will be the same. Maybe 18 feet here and 18 feet here. And that's how a parabola got its name. And then I can teach various things associated with that, how to graph it. But all of that information, how it's applied in real life. Imagine a water fountain. If you don't get the math right, it overshoots the bowl. Or it gets so high in the air, you have to get under it to take a drink. Math has real life applications. And by using visual imagery, concrete manipulatives, we can do things that can really help our students make sense of the math they're learning in school. So multisensory math uses as many sensory areas as possible. We use what's called the concrete, pictorial, or representational abstract instructional sequence. Have any of you ever heard of CRA, or concrete, representational, abstract as an instructional sequence? You just type into the chat yes or no. Great, some of you have. Excellent reactions, yes. So if you haven't heard of concrete representational abstract, and that's not your fault, it is an instructional sequence that is evidence-based, and it says that when children learn a concept by building it with concrete manipulatives, they're better able to pull up that memory and then apply it. So, for example, I'm going to reach for a bag. I'm in a small space here. If you are a tutor or a math teacher, you may know what base 10 system is and how when we align our numbers for addition and subtraction, they're usually aligned, they can be aligned vertically to represent what we're teaching. But for little kids and for older students who don't understand place value, we could take a simple, easily available manipulative and illustrate our base 10 system. So for example, did you know that we only have 2 civilizations in the history of mankind that have not had base 10? Why would we have base 10? Well, we have 10 fingers. Those civilizations that have not had base 10 have used base 20. So they must have used their toes as well. But when we teach our students, we teach them to count. And, face it, we all count on our fingers at some point or another just to keep track and self-monitor. But that base 10 system is the foundation of everything. So those of you who teach kindergarten and first grade, our students really need to illustrate it. They need to build it to know it. They need to understand it at a very basic level. So in our first Math 1 course, we talk about the foundations of math. And here is a graphic organizer. It's a place value mat that simply has ones and tens. And just as when we have 5 fingers, we can look at that and we can say, okay, if I have 5 fingers, 1, 2, 3, 4, 5, I count them. I can put my thumb over it. That's 5. I have 1, 2, 3, 4, put my thumb over. That's another 5. And we bundle them together and it makes 10. So we link it to what they know, their fingers when they're counting. And then we might use something that has mass or weight to it. And I'm going to have my students use craft sticks. 1, 2, 3, 4, and 5. Just like I have 5 fingers. And when I get another 5, 1, 2, 3, 4, 5. What do we do when we get 5 of anything? We bundle. Now imagine you're going to cook Thanksgiving dinner. This is a piece of the science of learning. It's called elaboration. It's linking from what a student knows to what is new. So for you, I'm going to say you're cooking Thanksgiving dinner and you're buying potatoes at the grocery store and you're holding them loosely in your arms. You may not even know how many you have. So it's better to put them in bags. And how do we bundle things like eggs? We bundle by 12. How do we bundle, other things? Maybe we have something that comes by a units of 10 or units of 24. Well, in place value, we're only allowed 9, just like your place at the dinner table. The way quantities are organized, they have their own place. So I'm going to bundle these, and I'm going to instruct my kindergarten or first grade students to use a ponytail elastic that's appropriate for their hands. And I'm going to bundle it by saying, I like to put my other hand here. I'm going to duck and twist, duck and twist. And I know how many are in there because I counted them. They're 10. I don't have to count them again. And from that, we build our teen numbers in kindergarten, which are based on language. In the old German, 11 was one left over after I bundled my 10. And we don't know how TWO was pronounced 1,000 years ago. It could have been TWO. And so 11 comes from the phrase elev, or one left over, one left. TWO left become 12. And then the Anglo-Saxons decided it was 3 left over after I counted my 10. So it's 3 and 10 or 13. And then it's 4 and 10 or 14 and 5 and 10 and so on. But as our children build the place value system, as they're learning cardinality, that when I get to 13, I have 13 objects, this is the concrete level of experience. And I can use that to learn to build in first grade my numbers to 100. I can even take my tens and say this number is made of 3 tens, 3 ones. Its name is 13. There is 33. I can ask them to add, and they can get to a point where in first grade, they're bundling those tens and they're building their numbers and they're naming them. And then finally we look at it and we say, you know what? If I had 8 individual sticks, not bundled, not like potatoes put in a bag, they're just loose, and I add 5 more to that, I get 1, 2, and I always put them in a pattern. That's from the science. It's called subitizing. 3, 4, 5. Can you see there that I have another 2 tallies? That means I've got an improper number. My goodness, that's 3013. What a silly number 3013 would be. I have to know that in the rules of place value, when I get 10 of anything, I bundle and it moves into the next organizational component of my number system, which is another place value. So by building it, our children can learn to add and subtract with regrouping. With subtraction, if I have this and I'm asked to take away 9, that's our first version of subtraction, I don't have enough in my ones place. We never say you can't take 9 from 3, because that would be making a rule that would expire. You can take 9 from 3. It's called integers in pre-algebra. So we have to make sure we give accurate instruction in the math concepts and the procedures. In order to subtract, I have to unbundle a 10, move them over here, and then I can take away 9. Now, the other piece of our math approach that is so critical for that, I wanted to demonstrate that because later, when we get to fraction instruction, the same thing holds true. We can show fractions with manipulative using the same type of place value math, but this time, instead of tens and ones, it might say ones and fractions of 1. And when I have 3 and 1/3 and I have to subtract 2/3, I've got to decompose or break up one of those ones to create the pieces I need to subtract. So our math program that's offered in the Aztec courses is conceptually based. Every operation, every concept is illustrated with a manipulative. And when we do that, we're asking our students to explicitly understand the meaning behind the math so that they can do problem solving, so that they can do legitimate, authentic applications. So these courses are taught in such a way, and I have to stop sharing. Zoom has changed its format, so I have to do things in a different way, and sometimes I forget. You know, wow, technology, the new iPhone, nothing's where it's supposed to be. It's what we all encounter. All right, so our math courses at Aztec are structured so that our content is conceptually oriented. And that first course is going to do all our foundations. But if you're a secondary teacher, I do require you to take Math 1, 2 in order to get to Math 2. Because if you don't understand how multiplication or fractions or place value are taught, at those lower grade levels. When you have students coming into your middle school class, you don't know how to provide intervention. And then our lesson plan that we use shows you how to fill those gaps, even as you're teaching grade level content. So let me guess, all of you all have all your students know their times tables at the end of third grade, right? I don't hear people laughing, but I don't hear anything because you're muted. But I see some smiles. And you're absolutely right. We have a lot of students. Yeah, Jennifer, oh, how I wish. There's even research out this year about how we teach fluency, and it's based on the science of learning, which goes back to study skills 40 years ago or more. And there are certain techniques we know about how we teach to maintain student retention and how they retain it over time. So, for example, if we teach fractions procedurally, just, top times the top and the bottom times the bottom, or keep, change, flip, our students don't remember it. But if you teach it with a manipulative and it makes sense, we can link from what we learn in a lower grade to what we need to learn now. And I will give you an example of that as well, and at different levels. But we have certain pieces where math is different than literacy. In math, we're building conceptual hierarchy. And so what you learn at that fourth grade level depends very heavily on what's taught at the K2 level. And if you miss that, it's like the Jenga puzzle, everything comes apart. The tower will not hold. And yet our students are going through school learning procedurally. They don't retain it. And then the fourth grade teacher has to go back and teach place value. And the seventh grade teacher has to go back and teach numeracy, the add-ins of 6 and 7 in order to do integers. And our algebra teachers have to go back and do multiplication and division in order to teach linear functions. It's one long continuous complexity piece that grows. So the goal of our approach in this math course is to give our teachers the capability, parents, tutors, to give you the capability of, first of all, spotting where the holes are. What are the gaps? How do I start to do that intervention and fill in the gaps even as I'm teaching fourth grade or seventh grade curriculum? That's what I do. And on our lesson plan, we use the science of learning to build our remedial content in the first few minutes of the lesson plan before going on. And there are certain strategies we use. Like I said, the new research on multiplication is that, yes, time drills are effective. The Mad Minute works, but not for every student. And we do have students who get math anxiety. We heard, the comment about math trauma. If you cook dinner for your family every night and every night they sit down and say, ugh, I'm not going to eat this stuff, you're going to stop cooking. And if a child goes into school every day and faces failure, they're going to stop wanting to learn. They're going to shut down. How do we reignite that spark? How do we get them to want to learn again? And the secret is success. We give them tools with which they can be successful, and we incrementally improve their skill and fluency and apply it at higher levels. So I'm going to give you a demonstration of the approach that goes higher, but let's go back and let me talk now about Math 2. So if our Math 1 course covers that K5 content and all the strategies, not only for initial teaching, but intervention, we basically get up to fractions and decimals. It's a 30-hour course, and I have that on this slides. The Math 2 course has a lot more information in it, and it goes from fractions to algebra and geometry. It's a longer course, really. I used to teach it in 30 hours, and people kept saying there's too much content. So it's now about 35 to 40 hours. And so those are the two courses we offer. I've developed this course over 25 years, and I want you to know that my goal is to validate our instructional strategies, the language of math, and the conceptual development, but I do it through alignment with evidence. This is not something I pulled out of the air. I'm going to tell you what research supports what we do at every level. And when I say gross motor works, that football, you know now that that's associated with quadratic equations. You know that 13 is 3 left over after I counted that 10. And we want to develop effective instruction and intervention strategies that gets rid of that math trauma or prevents it in the first place. And how do we do that in a standards-based learning environment? So I want you to know that reading is where we build sound symbol correspondence and structures. But you can't take a third grader who's learned literacy. Those of you who are literacy specialists, they know the 6 kinds of syllables, prefixes, and suffixes. You can't hand them Shakespeare. But math is different. That's the beauty of these two courses. We can take a 7th grader or 8th grader who's really struggling in math, and I can show you the skills you need to teach and how to teach them, where you can also teach with those number facts and those skills. You can be teaching algebra. You don't have to master all the times tables at one time. And in fact, fluency develops over time. So I say teach fewer facts at a time to develop fluency over time. So mathematics, you have the potential to make more gains more quickly if you know how to structure it. My teachers in my courses are reporting to me, oh my goodness, the craft sticks are a game changer. I had a 4th grader who didn't understand place value. I worked with him 2 days and all of a sudden he says, oh, that's what I'm doing. So I get these comments from teachers who are putting these practices into place. So the 2 courses are the foundation of what we teach, and we are trying to make them evidence-based. And so what we're now discussing in the math field is that how do we align that with the science of math? These are the key components. I'm not going to give you 97 things. These are key components of the science of learning that we used. That football player and pipe cleaner, that's called dual coding, where we give our students an image wedded to the words, and it provides the anchor for the concept and all the vocabulary. We also know that we want spaced practice over time. So you don't teach the whole 5 times table. You teach 4 pieces of the times table. You practice it chorally with your students. You show how it looks in numbers, but you mostly show how it looks in manipulatives, the tools, and then you practice it during class, like you do the choral chanting. You make your students write it down. They create what I call a near point reference. They write those numbers down on their graphic organizer on the desk where they can touch them as they use them. And then you use those numbers in your class instruction. Curricula usually they assume that all students learn their multiplication in 3rd grade. They assume that children have fluency they don't have. And so it's frustrating. That's part of what creates the trauma. If every time you try to get a multiplication fact, you got to skip count. Or every time you have to subtract, you have to count backwards on your fingers. We can do better than that. So these are the components of the science of learning that I am explicitly linking to every single instructional strategy in that course. Concrete example and dual coding we did with the pipe cleaner in the football, because it's a concrete example in real life of how the math looks, and that dual coding is the image and the words and the gross motor. So we're helping our students to learn by utilizing as many sensory areas as we can, all at the same time. So yes, many of our students come into 4th, 5th, or 8th or 9th grades without knowing their times tables, and we can fix that. Even in learning disabled students, we can fix it. You just need to know how. And it's not the traditional way of introduce the times table and put them on a time drill or a computer game. This is intentional teaching. you being the master teacher and deciding where your students are and diagnostically what they need to achieve the concepts and skills you want them to have to achieve that grade level content. Knowing that your curriculum is not something brought down from the mountain on tablets. If you can't deviate, you can't differentiate. So when you're talking about helping your own child or talking about helping your tutoring students, this specific approach is using evidence-based strategies from the Science of Learning, from the What Works Clearinghouse, and we're trying to match that to what's best for children. The other thing I want to put in the chat here, I'm going to give you a couple sources if after this meeting you want to look it up. One is called the What Works Clearinghouse Practice Guides. And I've got to spell it right because I'm typing. You don't have to read the whole practice guide, but in the very first pages of it, it will tell you what their core recommendations are from research. And they'll just tell you what they are. So for example, for children, small children who are struggling with math, they talk about short pieces of language, concise instructional language. So with place value, I say, what's it made of? What's its name? And I repeat that frequently so children can touch the craft sticks or the base 10 blocks and say, it's made of 2 10s, 7 1s. Its name is 27. It's made of 100, 4 10s, 9 1s. That's your expanded form that tells me what the number's made of so I can visualize it and I can think how big it is. You don't get big from the numerals. You get it from the size of the manipulative. And then what's its name? How do we read that number? So many of you may not know that we decode the 10s and the 1s together like it's a single syllable. 124, 378. And children need to learn to read those big numbers and visualize them so they can see what they're doing. So our courses are based on that neuroscience piece. They're based on the science of learning, the What Works Clearinghouse. And the courses are self-paced. They're between 30 and 40 hours. There is some recorded content and virtual live content. And we offer two 2-hour video conferences with Math 1 and with Math 2, some more for Math 2. But you choose which ones you want to go to. So there's one of my math team, one member, who teaches her video conferences in the morning. So if you're a tutor and you've got afternoon students, you go to that video conference. So we give you the opportunity to interact with the three of us. I'm your main instructor, but I have assistants who do the video conferences, and we clarify things, we do demonstrations, we make sure you're really on target. With me, you have daily contact by email or comments in the class. So if you're troubled or you have trouble logging in or something in the video isn't working or the website won't let you comment, you send me an email and I check it every day, and many times I check it multiple times a day. Graduate credits are offered. Now, these are some comments from my class just since January. I prefer in-person class, but this is the perfect class to take in this manner. There is so much information, I can't imagine taking it in a week. You get 2 months, between 2 and 3 months to complete the instruction. Another person said the ability to go back and forth in the videos allows for so much flexibility and deeper understanding so I can bring it to my lessons. I even have the ability where we have the videos housed that I can tell every time you log in how much of a video you watch. And if you watch a single segment 3 and 4 times, and I can see, well, in this one, everybody watches that one component like 4 or 5 times. And so you don't have to complete the video in one setting. It's not live. You can watch it at 3 in the morning, rocking the baby who's, got colic. You can watch it during your planning period. You can watch it after dinner or, do 4 hours of videos on a Saturday. But you have that chunk of time to be able to really interact with the videos and practice along with them. And I will tell you the other piece that's really important about these classes is the instructional language. I'll demonstrate that in a minute. But think about your content you're teaching, grade specific, grade band specific, or a remedial piece that you want to really work on with a student. The Math 2 course, what I hear here is things like across all of the readings, a clear theme emerges. Effective math instruction is intentional. It's language rich. It's guided in how the brain actually learns. Whether it's subitizing, building, around 10, or multisensory approaches, or explicitly teaching word problems. Each practice reinforces that math is not just about memorization, but about making meaning. That's from our Math 2 credit course this year, just since January. So the courses are there, and before I go into a practicum or anything, let me open the floor up to questions. Does anybody have a question, or you want to ask a question about a specific math concept? Just open up a mic and shoot me a message here. Don't everybody speak at once. Is there a practicum component required? That's a great question. I'm about to talk about it. We do have a practicum. So Jennifer, I want to go back. Have you had any experience in literacy with what a practicum is? Are you OG trained or anything literacy, structured literacy trained? Because other people may, yeah, you're a cult. I'm a cult too. Good. All right. So that tells me where your question's coming from. For those of you who are not trained in OG or multisensory structured language, a practicum is like practice teaching. It's like student teaching. And you work with a group of people at your level, and you meet with your supervisor. You practice the instructional strategies live with a student, and you can videotape it and send it in and get an observation and feedback and critique of your teaching. So simply taking the course, you don't get certified. You get what's called CEUs, continuing education units, that you can apply. Your school district may allow them if you are in something like an MSLIC or ALTA accredited organization like a CALT. So Jennifer, you could get these CEUs and apply them as your CEUs with ALTA. If you're an OG person, you have to acquire certain CEUs every year. So this is your continuing ongoing professional development. But then after you complete the courses and you say, well, this is really working for my students, can I do a practicum of teaching and be a certified practitioner? We have that, and it's growing. It's evolved in just 10 years. We've gone from a practicum that only had one level and 3 people in it to now having several practicums run and having, many people coming up through different levels. We have 4 levels to our practicum, and I'm going to get into that in a moment. But yes, you can be a certified, what the equivalent of a certified academic language therapist in math. And I'm going to go through the levels of the practicum. Does anybody else have a question about the courses that you would like to ask now, as before I go into the practicum?
Yeah, could I jump in and ask a quick question?
Absolutely. That's what this is for. Freewheeling discussion.
Do you have anywhere an overview of the topics you cover and some of the strategies you get into? A lot of this seems familiar, what you've discussed tonight, but I'm sure there's so much I have yet to learn, and so I'm just sort of curious to kind of place myself on the continuum and figure out if this is the right course at the right time for me.
That's a great question. I do have a list of the topics we cover, but again, because of the people in the class, sometimes more of the people are interested in intervention, some are, but the topics we cover in the math is that vertical hierarchy of concepts. So we go from we have a small preschool unit, which talks about that language piece. We do numeracy and subitizing. We connect that to place value, addition and subtraction. We go over all the operations, and all of our instruction is going to do concrete representational abstract so that everything will be illustrated. Then we go toward our lesson plan and intervention. How do we structure our instruction? And it follows an OG lesson plan format. And you may not know what that is, but we have a lesson plan that includes that intervention piece. Then we do multiplication and division and in multiple ways, because this is what's really important, Christina. The What Works Clearinghouse says that in order for our students to really understand the math, they need multiple representations. So I might build multiplication with unifix cubes. I might have them draw it on a number line. I might have them color in the multiples of a number on a hundreds chart. And eventually, we're going to go to my chief tool that I use, which is this one. So you've given me a perfect opening to show you how this might be different than what you've studied. This is one of the first things I developed for a very severely disabled, learning disabled 7th grader, and I call it Strings with Wings. So I'm going to go here, just a real short one to show you how this is the explicit language. This is just 9mm pony beads. It's on a shoestring. And for my students who are really struggling, for those of you who know students who have had math trauma, they're really afraid of multiplication. So we're going to illustrate what multiplication is by making many groups of the same quantity. And frequently in our summer intervention that I have, a program, my older students really don't know all their times tables. They've got some familiarity with 2s, 3s, and 5s and 10s, and that's about it. So I deliberately pick one of the upper times tables. And before I go into this, I want to say that some of the neuroscience is truly interesting. So Christina, what we do know about multiplication is, from the brain imaging studies, is that addition and subtraction facts are largely visualized as patterns, like tally marks or dice or domino patterns. And we can actually teach children to anchor their imagery for addition and subtraction in visual imagery. We will eventually go to 10 frames. You may have, used those in your teaching. But place value concepts are central. When we get to multiplication, though, this is fairly recent. This is after the fMRI studies came in, and we looked at Stanislas Dehaene's work from France. And we're learning that in multiplication, it's word retrieval. I can visualize a domino with 5 plus 3, but I can't visualize 6 times 7 is 42. So how do we make our students who have language retrieval problems, especially our students with dyslexia, how can I help them to visualize the multiplication and division? The second piece is that based on the research on subitizing, the human brain can see 4 things without counting. I don't have to have you count that to see that it's 4 groups of 7. The minute I add more than 4, you have to count. And that also dictates how we use base 10 blocks when we're teaching place value. So this is 4 groups of 7, and I would take my students through a sequence of pointing and moving the beads and showing what 3 groups of 7 is. They would get lots of repetition in 1 group of 7 is 7, 2 groups of 7 is 14, 3 groups of 7 is 21. Let's count that again. 7, 14, 21. How many groups of 7 was that? 3. What's the total? What's the product? 21. 4 groups of 7 is 28. On the first day, that's all we learn. But where that's going to go is that I'm going to teach inverse operations at the same time. So I'm going to say, if I have 21, can you look at your string and tell me how many groups of 7 I can make? There are two versions of division. Unfortunately, many curricula teach the more difficult one first. And I'm going to make a connection here to a lower skill. We all know that subtraction, the takeaway model, 8 take away 3, that's the first method, the first model of subtraction we learned. But we know that subtraction is also comparison. How is 8 compared to 3 or 5? And that's also a subtraction version, but it's the second one we teach. In division, we can do equal sharing, but if you don't know your times tables, it's really difficult to do word problems. And so making groups of 7 is easier than making 7 groups and asking how many are in each group. So here's 21. You can see that it's 3 groups of 7. But if I said, look at this, and if you don't know the times table fact, I'm making 7 groups, how many are in each group? Visually, it's different. So now you know that's 21, but suppose I said I have 23. How many groups of 7 can I make? 23 divided by 7 is 3 with a remainder of 2. Now you can explicitly see what the remainder is. And by 6th grade, that standard is that it's 2 out of the 7 I need to make a new group. And that links directly to division of fractions. So everything we do is building those concepts right up the food chain to the next grade level and the next concept. So from this, I can do division with remainders. I can look at this and say, okay, we're in 4th grade now. Can you tell me what 2 of the 3 groups that make 21 is? 2 of the 3 groups would be 14. So 2/3 of 21 is 14. I charge you now as a teacher, look at 28 and tell me what 3/4 of 28 is. 3 of the 4 equal groups that make 28. I could take that to 6th grade and say what's 75% of 28. If I take 28 and I multiply it by 0.25 or 1/4, what is 1/4 of 28? The visual anchor helps them to reason mathematically. And if I want to take that even further, I can say to my students, we've just done percentages and fractions. I want you to think of a number line and think of 4 parts. We've just done 4 parts of 28. Let's see if we can apply that knowledge to another times table. So if this is not 28, but it's just 8, can you tell me what 75% of 8 is? Can you tell me what 75% of 80 is? If I made that instead of 8 and I made it 12, what's 3 of the 4 groups that make 12? What would the halfway point be? And what would the next 4th be added to that? Can I figure my numbers? And if I can do 12, can I apply that to 120? Can I apply it to 1,200? That's math reasoning based on the initial explicit instruction and skill. And last but not least, for you 4th and 5th grade and 6th grade teachers, if I had 7 beads and I cut each bead in half, how many 1/2 pieces of beads would I have? I'd have 14. So 7 divided by 1/2 is 14. I can see it. It's not like the teacher says, well, when you divide by a fraction, you get a bigger number, because the teacher doesn't understand the concept. So if I take 7 and I cut each of those into 3 equal parts, how many 1/3 of a bead parts would I have? I would have 21. That's based on my knowledge of the initial instruction with a concrete. I can go to pictorial. I can take that and draw 6 circles, and I can say, what is 1 of 3 equal parts of 6? Well, I can see my 3 equal parts. So 2/3 of 6 is going to be 4. and 2/3 of 60 is going to be 40. We don't want to deny any student rigor, but our students who have to just memorize words for procedures don't get it to stick so they can visualize it and apply it at higher levels. So that concrete pictorial abstract sequence can be very helpful. So for example, if I took a place value mat, which I just had, let's see if I moved it. Let's see, where did I put that place value mat? I love plastic sheet protectors for students to do dry erase with. So, no, that's not it. Oh, here it is. I set it on my other side. Okay, so let's take this one and let's do place value with craft sticks. Now, a kindergartner can do this. I'm going to draw my craft stick now, and I'm going to draw a bundle of 10. And I'm going to do another bundle of 10 by first grade. And I'm going to put 5 always in a pattern and 1 more. And I'm going to do another bundle of 10. That number is made of 3 10s, 6 1s. Its name is 36. And if I add 5 more to 36, I can see that I have too many in my ones place. I have 3011. What a silly number. I have to bundle that 10, and I've got, because I've already counted it, it goes over here and it goes away from my ones place. Base 10 blocks you have to exchange, and it doesn't obey the laws of conservation of quantity. So that concrete pictorial abstract sequence is really important, and it goes all the way up to algebra, and it goes to geometry. We're making math visual, all right? So let me close this, and I'll get to the practicum, all right? So yes, so Jennifer, we have a 4-level practicum, and we are working with the OG Academy, OGA, to develop a pathway to certification in math. 2 years ago, I was named a fellow of the Academy, and last year they named me as the founding fellow in math. So I'm the instructor. I go back to my first OG training in 1976 with Julia Herbert, who studied with Diana King here in Silver Spring, Maryland, at the come on, name of the school.
Sidwell.
Sidwell. Yeah, she taught at Sidwell Friends. Diana King was here teaching at Sidwell Friends for teachers. And during the 1960s, Anna Gillingham herself came down here and worked with teachers. And my trainer trained with Diana King in the 60s. I'm assuming she may have interacted with Anna Gillingham, but they didn't keep records then, so we can't know for sure. And so I taught in a public school, one of the first public school dyslexia programs in the country. And I taught until 1985 in a reading and language program where I had as many as 38 dyslexic students in a class at one time. My low skill group with 8th graders reading at a 2nd grade level, I might have had 28, 27 in a class. I did that for many years. I certified as a CALT. I developed this multisensory math approach beginning in 2003 when Dr. Joyce Steeves retired, and I revamped it with some of the other CALTs at ASDEC. We said, well, what do we want in a math manual? What needs to be in a course? How does it be better organized and more structured? And that's a comment I got just last night on a video course, on my video conference for my math class. One lady, she was in Taipei. Last night I had Taipei on my video conference, and she said, this is the best organized course I've ever taken. So that last year, I was named the founding fellow in math with OGA. So here's what our practicum is. We're working with OG. It hasn't been solidified yet. We've been working about 3 years to try to make our practicum align with their practice philosophy standards, but most of all, the intensity of the training. The training has to be rigorous because our people are credentialed, and it's a separate layer of credentialing. Just like if you're an English language arts teacher and you get to be an OG associate, you know more. You can do better in terms of intervention. And so we started in 2015 with the practitioner. This year, we have 4 levels of certification. Each practicum level requires a minimum of 10 months. It's a year practicum, just like you were doing one in a MSLIC or Alta or OG, and a maximum of 4 years. So if you want to perfect your skills and you want to stay in the practicum in math, you don't pay anymore the next year. You just stay in it and you do your required number of observations. You're welcome to attend the meetings, do the assignments, and develop your skills and work with your supervisor. We have a monthly virtual group meeting with the supervisor, and it is considered coursework. So where in a traditional practicum, you would work with your supervisor and do observations, and then you got to pay for a course separately. Our practicum may be a little more expensive, but it includes the coursework and the guidance. The assignments and readings are determined by the supervisor, and you have to do a set number of observations. Our first level is Certified Multisensory Math Practitioner. Now, I'm going to tell you, in working with the Academy, there may be some tweaks to this, but this is how it is right now. That person is able to deliver instruction using our lesson plan and our core instructional strategies. You adapt that to support any curriculum, or do resource work or small group work or pull out or push in work. And you can do tier 1 and 2 intervention. So before a child gets too far behind, you can get that small group together and say, okay, let's review place value a little more, intensely, or let's explore and do some problem solving with fractions. The level 2 has just recently changed in my work with the OG Academy. This is becoming our therapy level. So this is an individual who can deliver instruction, which is truly diagnostic and prescriptive. The difference is the level 1 practitioner can deliver the instruction, but it's not necessarily geared to the neuropsych. So for example, if a child comes in with a neuropsych and it says, well, this is a child in the 65th percentile cognitively and has working memory in the 23rd percentile, I can look at that parent and say, well, your kid's driving a Ferrari and he's got a 25-mile-an-hour speed limiter on it. That engine's revving and it can't get the gas in it fast enough to go as far as it would like to go. So the specialist is the person who's going to do that diagnostic prescriptive approach. And this would be level tier 3 and tier 4 intervention. And you can design instruction to meet the specific needs of a student or a small group. The next level up is our clinical supervisor. This is a person who's finished the other 2 levels and is able to deliver staff support. So I now have schools that want an on-site tutor, a trainer rather than putting 3 to 5 people in my course every year, which gets to be expensive. They're investing in a practicum person who can deliver that coaching at their school. Because, you spend a certain amount of money for a course and the teacher gets transferred to California and you've lost that investment. So if you have an on-site trainer, you're investing in the practicum rather than putting masses of people through the courses. So this certified clinical supervisor is coaching and is getting coaching experience. My group this year we're looking at 3 or 4 different models of coaching in schools and how schools have developed their math program in that school or that district. I have public school teachers, private school, independent school people. I have people who are at learning centers learning to be this clinical supervisor so that they can go out and do professional development workshops. These people begin to do presentations. So they may offer a practicum under the supervision of a master teacher or a teacher in training. And so we filter people up through the pipeline getting various levels of expertise. The level 4, to attain that, you become a certified instructor. And I have people right now studying to become me. You co-teach with me. You're able to offer multisensory math courses on your own and get critiqued. So for example, I will be co-teaching a Math 2 course virtually this summer with someone who's going to be a certified instructor. She will be offering it on site and I will be coming in virtually to support her. So we will be co-teaching, working together to develop things. So those are our 4 levels. For the level 1, 2, and 3, you don't need a master's. You need a bachelor's degree. You have to complete each course according to the levels. In the first level, you complete Multisensory Math 1. For CAVE 5 certification, you need 5 successful observations delivering the structured math lesson plan. And if you're doing K8, and this is one thing I'm insisting on, my secondary teachers have to have the ability to certify at the practitioner level. We're not going to wait until you have to invest in another practicum. So you got to be able to do that in the level 1. But you have more observations. And the reason for that is if you are an 8th grade algebra teacher, you still have to know how numeracy is taught in 2nd grade in order to provide intervention. You need to know how place value is taught in kindergarten, 1st and 2nd grades. You need to know how to remediate multiplication and division problems. You need to know especially fractions. Like for many teachers, elementary teachers, fractions are the mystery of the universe. And so when I demonstrate that language for you, you're going to see the connections to that string with the beads on it. And so for levels 1 and 2, you only need the bachelor's. To go to supervising others, that's level 3. You still can do that with a bachelor's degree. But to become an instructor, you have to have a master's. And that's similar to ALTA and MSLIC.
Marilyn, there's a question about the summer boot camp or this. I'm imagining that's a summer camp.
That is the summer camp at ASDEC. It's here. We don't do it virtually online. We did once during the pandemic, but we don't do that because it's for children. It's really important to have them, in person, because this is often our students who are dyslexic and are really frustrated because they're bright and they know that they're not accomplishing what they want in math. It was originally designed for students with dyslexia. It's small group instruction, no more than 12 in a class, often fewer than that. We want children who are not, so attention deficit they can't attend. You have to be able to work independently in a group with manipulatives. But we do have a variety of learning challenges. My approach now for math is being used not only for dyslexia, but it's being used for ADHD, children with executive function disorder, hearing impaired students. It's being used in 2 university settings to teach deaf children. I've had people working. I have one teacher in a public school near here who said, I have a student, I'm an ESOL teacher. It's used with ESOL students, by the way, because of the explicit language I use. So the summer program is 3 weeks. It's an hour and a half a day, 5 days a week for 3 weeks, and the students have to attend for the whole program. Otherwise, they miss things. And so they come and we have this, what I call my elastic scope and sequence. So for the older students, grades 3, 5, and up, I have getting ready for middle school. That's our 3, 5 content. And those are children who are often behind in those basic concepts and skills. And we will do addition, subtraction of whole numbers. But this is what's different about my approach. In that elastic scope and sequence, you look at commonalities. And one of the most important things you look for in testing is what does the student try or attempt on the intake assessment? Because if they've been introduced to something, there's some familiarity that you can build on. It's not like you're doing initial instruction on fractions. So often, because you're building on previous knowledge and they just didn't understand it, we can move a little faster. We can go into things a little more clearly and really build that knowledge. Almost every one of my algebra prep group, really, they all need long division. So that first week I do addition and subtraction, numeracy, place value, and I do addition and subtraction of whole numbers and addition and subtraction of unit fractions with the older students because there's similarity and regrouping. The second week we focus on multiplication and division while doing interleaved practice with place value, addition, subtraction. And we go into more little bits of multiplication and division of fractions. And then depending upon the group, and that is always the case, we see how far we can go. In my algebra prep group, which can be anything from really pretty good 6th and 7th graders up to students who are in 8th or 9th grade and struggling. And we might have them all in one group. And we will start always with numeracy and place value. Basic operations will move a little more quickly. And by the 3rd week, we're into linear functions. And we do have a group of rising 4th graders. We don't take 1st and 2nd graders, but we do take rising 4th graders who are really struggling, and we work with them. But it's all small group.
We are coming up on 2 hours. This has been hugely helpful with lots of information. Does anyone have any more questions about going back to the courses? We have a spring course coming up, starts in March. Basically, Maryland offers them 4 times a year, seasonally. So then we'll have summer and then we'll have fall again.
And I will say they're depending upon your schedule. You know, if you're a classroom teacher and you're going to be crushed at the end of June, you might decide, well, I want to take the summer class. If you know that you want your summer off and you want to have it really gel over the summer, take the spring class.
Yeah.
The course with the fewest people is usually the winter class. It starts in January, and I can give a whole lot more attention. But we can have anywhere from 40 to 90 people in a class in that online class, which is why I have my assistants also help me with talking to people. But for example, last night on our video conference for Math 1, we had 2 hours. And then I said, I'll stay on 15 minutes or so to answer questions. And an hour later, I was helping a resource teacher figure out how to deal with her 4 children in her class and giving her specific help because one was so hungry for learning. She was finally being successful. And the other child she was struggling with was so ADHD that she was like putting her hands on his hands constantly. And I was telling her, well, let's modify the instruction this way. Let's try this. Let's try that. And she'll write back to me and she'll tell me what's working and what's not.
Yeah, so it's really interactive, which is great.
It's very interactive. And people will email me and say, I tried this, or I need one more little tweak. And sometimes I meet with them for a few minutes. And both courses are offered for graduate credit, by the way. And the practicum is also offered for graduate credit. So that's something else to keep in mind.
Right.
Any other questions? Anybody want to know something? So if you want to stay on after our time's up and I show you the link between strings with wings and the fraction division, I'll demonstrate that for 5 minutes, but I want to let people go who need to leave.
Yeah.
So if you're really hungry for fractions, you can stay on and say, just show me one division of fraction with manipulatives and I can rock your world.
Thanks, everybody. We'll also send the recording out because this is a lot of information. You'll have opportunities to go back. Thank you, Marilyn. Thanks, everybody, for showing up. Okay.
So, this is mine. So
this is yours. Yeah.
Oh,
so you can
so
say
I'm going to end the video here.
Oh, right.
Anyone
the recording.
wants me to rock there, I'll end the recording here and say, lovely, thank you for coming and for your interest in our courses. And I'll be at the OG conference in Norfolk this year. And I usually present at IDA almost every year. And I'm out there. So just reach out.
Thanks, everybody.
Turn the recording off now.